This is a review of question 4 in exam 4. The two stars in a binary star system rotate in circular orbits about the center of mass of the two stars. Consider such a system where the two stars have the same mass, 2.0 times 10 to the 30 kilograms. They're separated by 2.0 times 10 to the 12 meters. In part A, we're asked to calculate the force that causes them to rotate. So let's do a drawing first. Here we have the first mass separated by a distance r. Each mass is the same. They each rotate about a distance r1, where r1 is equal to the distance that each is from the center of mass. So it's equal to r over 2. The force that causes them to rotate is the force of centripetal force, is the source of centripetal force, which is a gravitational force each exerts on the other. So we calculate that force, F sub g, equal to big G times the mass of the first mass times the mass of the second mass, which is m squared, over the distance of separation between the two masses squared. Well, r, remember, is equal to 2.0 times 10 to the 12 meters. So we put in the numbers to perform this calculation. Big G is 6.67 times 10 to the minus 11. And the masses are each 2.0 times 10 to the 30 kilograms. So we're going to square that. Let me just eliminate these units. And we divide that by the distance, 2.0 times 10 to the 12 meters, and that's going to be squared. And if everything in this calculation is in SI units, then the result of the calculation is going to be units of newtons. I perform the calculation and I get 6.67 times 10 to the 25th newtons. Part B, in Part B, we're asked to calculate the angular velocity of each star. Well, the force that one star exerts to the other, on the other, which we just calculated, causes the other star to rotate in around the circle of radius r1, which is equal to the total distance divided by 2. And this causes the mass to have this centripetal force and a centripetal acceleration equal to v squared over r1, or is equal to r1 times omega squared. So from this expression, we see that omega squared is equal to f sub g over m r1. So omega is equal to the square root of f sub g over m r1. So that's the square root of 6.67 times 10 to the 25th newtons over the mass of the star, which is 2.0 times 10 to the 30 kilograms, over R1, which is 1 times 10 to the 12th meters. And when you perform that calculation, you get a result 5.77 times 10 to the minus 9 radians per second. So that's part B. In part C, we're asked to find the period. Well, if we know what the angular velocity is, we know that the period is equal to 2 pi over the angular velocity. We know this because the angular velocity, that is, the rate of change in angle of a complete revolution, is equal to the distance of a complete revolution, which is 2 pi radian, over the time for a complete revolution, which is a period. So from that we know that the period is equal to 2 pi over omega, which is equal to 2 pi over 5.77 times 10 to the minus 9 radians per second. And that period then is 1.09 times 10 to the 9 seconds. And then we want to convert that to Earth days. And we know that there are 3,600 seconds in an hour. So that's divided by 3,600. We've changed this to hours. And then we know that there are 24 hours in a day. So seconds cancel and hours cancel to get days. And the result is 12.5 times 10 to the third days. Okay, so that's part C. Then in part D, what is the total angular momentum in SI units? Well, the total angular momentum is the sum of the angular momentum of each mass. So that's equal to 2 times little l, which is 2 times the mass times the distance r1 times the tangential velocity or 2, since the tangential velocity is equal to r times omega, is equal to 2 times the mass times r1 squared times omega, which we've already calculated in part B. So let's put in the numbers. This is 2 times the mass, which is 2.0 times 10 to the 30 kilograms, times R1, which is 1.0 times 10 to the 12 meters, and that's squared, times omega, which is 5.77 times 10 to the minus 9 radians per second. And our answer is 2.31 times 10 to the 46. Yeah, let me make that more visible. Kilogram meter squared per second. And that concludes this review of question 4 in exam 4.